All right, so I'm going to be talking about how pH affects bacteria. So bacteria will grow best at a pH of 6.5 to 7.5. That's going to be where bacteria will thrive, purely just because everything in our environment, your bodies, the food we eat, the water we drink, everything like that sits at a pH of around 7. So anything that is more than 7 is considered alkaline. Anything that is less than 7 is considered acidic. So in terms of bacteria and their resistance to pH and what they prefer and their relationship with pH, it's broken down into three kind of categories or three names. Acidophiles are bacteria that grow or that thrive in environments with acidic pHs, such as anything less than 5.5 or less than 7. Acidophiles are not an actual threat to humans. They're not really pathogenic because humans sit at a pH of 7. It's too absolute, I will say, to completely say that they're not pathogenic, that they're not harmful, but for the most part, they're not pathogenic. So acidophiles, not a big threat to humans. Neutrophils are going to be the most pathogenic just because they thrive in that pH range where 7 kind of fits in. So between 5.5 and 8.5 are where neutrophils are going to have the time of their lives. So neutrophils, the most common bacteria, definitely the biggest threat to humans. Alkalophiles grow at pHs greater than 8. Again, too absolute to be like they're not pathogenic at all. But for the sake of this video and for the sake of most exams, alkalophiles are not pathogenic and not harmful to humans. So I did kind of draw out this chart here a little bit. You can see purple are the acidophiles, blue are the neutrophils, and then in red are the alkalophiles. Okay, so also pH is actually a contributor to food preservation, fermentation, the bacteria that ferment and stuff like that, such as lactic acid bacteria and yeasts and stuff like that, actually produce acids like lactic acid that are going to drop the pH, and it's going to create a very acidic environment where bacteria is not going to thrive. Something important to know, acidophiles are not the majority of bacteria. There's not that many acidophiles actually thriving in the environment just because most of the environment is not acidic. The reason that this acidic environment is so stressful and bad for the bacteria, it's going to acidify the cytoplasm, which is going to, in return, mess up the metabolic pathways with the bacteria. Bacteria is not going to be able to grow because they're not going to be able to produce energy. Food preservation also is not just the fact that it's acidic. Majority of the time, salt is involved. So like salted meat is a way to preserve food, purely just because salt will create a hypertonic environment for the bacteria. It's going to cause osmotic lysis or plasmolysis. Plasmolysis is when the cytoplasm is getting drained out of the bacteria. So it will create a very hypertonic environment for bacteria. It's not going to survive. That is part of the reason why food preservation and stuff like that is so useful. Something I wrote down here is that bacteria produce acidic byproducts just naturally. They kind of end up poisoning their environment. So naturally, they're lowering their environment's pH. Not really important to know. I just thought I would add that in there. And then something that I do kind of want to mention, I feel like this is very, you can grasp this concept on your own. At this peak here, so that's going to be the optimal pH where bacteria is going to grow, depending on what category they fall under. The activity at that pH will definitely start to drop. So similar to when I was talking about temperature within bacteria, at its peak and optimal temperature, it's eventually going to be too hot, and that's when enzymes are going to start to denature. So same kind of concept with pH. At that optimal pH, right after that, the pH will either get too alkaline or too acidic, and then the enzyme activity will eventually drop off. So yeah, quick overview: acidophiles, neutrophils, alkalophiles. Chart is here. You can find this online. And if your professor asks, fermentation creates an acidic environment for bacteria.